Hello, everyone, and thank you for joining us on today's Senza Fili Sparring Partners webinar on sustainable energy, a boost from next-gen wireless and edge computing. Our speakers today are Yves Schuler, Principal Engineer and Director of Emerging IoT Networks at Intel, and Monica Paolini, Principal at Senza Fili. I'm Kendra Chamberlain, and I will be moderating our webinar today. In Sparring Partners webinars, we watch our debaters discuss a topic live on screen without many slides. We'd like to encourage our audience to participate in the conversation. Please share your comments and questions through the Q&A box in the Zoom taskbar. All comments are visible to all participants, so please keep the conversation polite and respectful. Our speakers will do their best to address comments as they go along and as they become relevant to the topics being discussed. So please do not hold your questions until the end. And finally, we will be live tweeting today's webinar. You can participate in the conversation using the hashtag Sparring Partners. And with that, I'll hand it over to Monica.
Kendra, thanks for the introduction, and it's a pleasure to be here and to talk about utilities. If you follow what I write, you know that I'm really interested in utilities because for wireless, because they are, this ideal vertical where there are so many things you can do, so many requirements that it's really one vertical where anything can happen and will happen and is happening. And so it's a pleasure to talk to Yves today. And we talked before a little bit, and my cat is making his own appearance, the uninvited guest. So with that, I would like to have Eve to introduce herself, and then we will have the usual conversation. So Eve, thanks a lot for taking the time to talk to us today, with us today.
Thank you so much. I'm really excited to be here today to really give the perspective of someone who's been in the the business of internet architecture for her whole career. My background is really in networking and distributed systems. And throughout my career, I have focused on the development of internet standards. And in the past, I've been involved in really internet telephony signaling protocols and real-time multimedia teleconferencing protocols. But more recently, in my capacity at Intel, I'm currently focused on the development of standards for deterministic networks and quality of service in industrial systems, as well as data management for edge computing. And additionally, focusing on kind of my newest focus has been on carbon footprint monitoring and reporting. And although these may seem like really disparate topics, you'll see today that they all hold some potential as playing important role as building blocks for this topic that we're going to be discussing here today. In my role at Intel, I span a couple of different organizations. One is focused on next generation standards, and the other is the Internet of Things group, which plays a huge role in what's happening to the internet architecture and the disruption that is underway. As part of the Internet of Things group, I am closely affiliated with the Industrial Solutions Division, which in turn has its own energy group. And so hopefully we'll get to talk a little bit about some of what they're doing today as well.
Yeah, and this is I think the interesting thing these days is that you got all the sort of vertical requirements, which are in some way news to the telecoms industry, and we have a new way to deal with them. So this is all very exciting because it's new stuff, but at the same time we're building on what we have learned before in our lives, where we were more focused on different types of networks. Although utilities have been doing wireless forever, but it was more using a different type of technologies. And in fact, today what we're going to talk, so I'm writing a paper on the need for utilities to move from legacy to next-gen wireless technologies. And as soon as it is available, you will be the first ones to receive it. But today, what we're going to talk is not so much of the technologies that you can use, but what you can use them for. And so clearly utilities need to move beyond legacy, but also they have a lot of other constraints. And I would like you to talk about it in terms of what is it they need to do differently in terms of how is the demand changing, what is it they need to do in terms of regulation, sustainability, need to be more sustainable. So maybe let's start with demand. How is it changing? We know that data consumption is rising, but that's not the only thing that is rising in the world, right?
Right. In fact, Kendra, if you wouldn't mind displaying the one slide that we contributed to the session, that would be great. Okay. So this is the backdrop for this discussion, at least, coming from, again, my perspective around the information communication technology sector. And what you can see here is that this is a graph showing electricity usage and how it is growing significantly. Where we are right now is we are, as an industry, we are consuming between 2 and 3% of all electricity produced, and that's 2020 numbers. And this is a curve. These are a set of curves that display the projected usage by 2030. One of the questions to raise, of course, is can we change the trends for these curves? But in the meantime, to give you a sense of this, if we look at the amount of electricity that data centers, for example, are consuming, that is the part of the curve that's in the bright aqua blue. And so we hear a lot of discussion about how can we reduce the carbon footprint, and in turn, that includes electricity usage of data centers. But then the next three colors, the yellow, the orange, the purple, are all network related consumption curves. And what you can see from that is that the network consumes as much or more than the data centers. So that's very much a part of this conversation today. To give you a sense of kind of how does this all compare to something that we could get our heads around, I've also included something here that shows what Germany as a country consumes per year. And so you can see that the ICT community has the potential to really be using quite a significant amount of electricity. So this discussion starts there, but by no means ends there. The forecasts for 2030 are anywhere from where we are now in the 2% range to using up 24%. That's a quarter of the electricity rate. So we need to do something about that.
This is a great graph. Is it me creating a eco? Okay, let's try again. It's a great graph. I really love it. And, as a user of consumer device, it makes me feel good because that's the only category that is not growing. So I can get some more devices and be still okay with that. But this is really interesting in a sense, and it's not too surprising to see that we have an increase in use because we're doing more. We need more connectivity. So obviously that has to come, that is going to require more consumption. But at the same time, you're also trying to reduce consumption on a per item basis by being more sustainable or by using different sources of energy to reduce the impact of, okay, we are bad in terms of usage, but how can we do to be less bad or be less disruptive so we can be more sustainable, right? So there is, from a utility point of view, there are these two parts: more demand, but try to be more efficient.
Right. So something else that I should mention, when we're talking about trends, is this trend for renewables integration. There's barely a newspaper or news feed that goes by without mention of this shift to clean energy. And one of the issues with that however, is that it's kind of an inherent problem with renewables, which is that the demand and supply for renewables are out of sync with the need for renewables. And so the more renewables that we integrate into the grid, the more we are unable to use all of those renewables. And so we're making good progress on renewable integration, but one of the big questions is, how do we take advantage of, are there some techniques that we can do to take advantage of this excess, or what we refer to as stranded renewable energy, which could help us in terms of moving towards clean energy and reducing carbon footprint and in climate change. In California, for example, because of this issue with integration of renewables, we're having higher and higher percentages of stranded energy. So the more renewables we have, the more stranded or excess energy there is. And unfortunately, what that dynamic leads to is, when we have excess energy, we sell it inexpensively to our neighbors like Arizona, who then sell it back to us when we have a demand for it, but they sell it back to us, of course, at higher prices. So increasingly, even though we're doing the right thing in terms of integrating renewables, we end up paying more for our energy, even though at face value, the renewables are cheaper than fossil.
So there is a lot of scope there to improve the efficiency, because clearly with renewables, solar power is there. We can use it, we get access. So, and we can get more than we really need on a real-time basis. So we need to be able to store it, but at the moment you try to store it, you have to manage that storage energy. So it's I guess that, from a traditional utility point of view, that's a new issue. That's a new thing. It's a new opportunity, but it's also something you need to manage. Now, before we go there, well, first of all, I would like to ask all the audience, if you have any questions. As Kendra said, you need to give them to us now. There's going to be no Q&A at the end. We take your questions as we go along. So go ahead and ask questions. But we did have a question and others from the audience ahead of the webinar, and one was about climate change. And I think that is something that we can address earlier right now. And the question was, is this going to help with climate change? And clearly, yes. But can you give us a little bit more of a perspective? How is that going to happen?
Right. So, I've kind of queued up the fact that there are a couple of these problems. One being we're using more and more electricity, not only as the ICT ecosystem and industry, but we are trying to do the right thing with renewables by integrating more renewables, clean energy into the grid. But we're not having a lot of success matching up supply and demand. So one of the solutions that comes out of the data center community, and in fact the hyperscaler community, is that we are beginning to see our cloud service providers, like the Googles of the world, think about, how do we take workloads that are time elastic and shiftable, and time shift them so that they align better with when the electricity is available, the renewables are available. In fact, you will often see that hyperscalers are co-located with hydroelectric plants to sort of ease the integration of renewables. And so you can think of the data centers as balancing out this excess or stranded energy. And so that's one of the solutions that has come along to mediate or moderate this problem of renewables going unused. Now, when we look at that from the question around climate, how is this going to affect climate? Well, we're hoping that clearly, this will allow us to move towards not only the integration of renewables, but the usage of renewables and greater efficiencies. The bigger problem also, and I think this relates to this other trend that we're seeing, is moving towards if you look at the industries that have impact on electricity consumption or even carbon footprint, as I said before, carbon footprint is kind of an umbrella term for for all the emissions, but electricity is a huge part of that. So in fact, electricity and electricity generation accounts for about 25% of greenhouse gas emissions. So if we can even make the industries like electricity generation or oil and gas or agriculture or industrial automation more efficient, then that will help us bring down our carbon footprint. So one question might be, how do we do that? One of the goals at Intel, for example, and this is the other trend I was going to mention, is that almost every company now has given themselves directives to be more socially responsible on a whole range of dimensions there, but one of which is sustainability. And that's no surprise if you look at what's happening in the regulatory domain. Increasingly, right now, all of our reporting for our greenhouse gas emissions or our carbon footprint, and I use those terms interchangeably, we are voluntarily reporting those kinds of things. But increasingly in countries around the world, those regulations in short order, because of climate change, are likely to lead us to we're going to be required not only to reduce our emissions and our carbon footprint, but to prove it and show percentage increases by certain times, whether that's 2030 or 2050, if you look at the Paris Accord. So that's another trend that's happening, is that companies are taking up the call because they see the writing on the wall from a regulatory standpoint that may be required of us in the future.
Yeah, absolutely. And so there is a sort of a concerted effort. So the technology allows it, but we want to do it. I mean, there is sort of a motivation in this regulatory and social. So there is all sorts of things that are sort of coming together to create the momentum to do this. Yes. Because clearly for a company like Intel or a utility, that requires some work. So you need to kind of justify the effort. Is there a reason to do that? And now let's look at it from a sort of how can wireless really help? And so for traditionally, a lot of the sort of the management of energy was simpler, and so you didn't need that much of a telecom infrastructure. But now, as the things get a little bit more complicated, there is a need for telecoms, and there is an advantage specifically for wireless telecoms. And on top of that, for a lot of infrastructure that is not centralized but is distributed through the footprint of the utility. So it's not just in their headquarters or in the central location or even in the cloud, but really is pushed out to all the locations where they operate. Generation, distribution, transmission, microgrids, homes, where you plug in your car. So there is many more places where you do need connectivity, and it's not just a centralized network. It's more than that. So can you talk a little bit about, and I think that this is where your experience in telecoms networks, which is really, is really relevant. How is this? Why do utilities? I'm assuming that this is the case. Utilities do need to have more wireless. So how do you see that playing into the utilities evolution?
I think let's back up a little bit, because we've talked about data centers, we've talked about renewables. There's this other phenomenon happening, which is the Internet of Things. And you mentioned it earlier, where you alluded to the fact that there's so much data that has emerged, and that has really shifted the need. What's happened is that the Internet of Things is this phenomenon where, at this point, billions of devices are connecting to the network, and they in turn are generating zettabytes worth of data, and about half of which is generated and analyzed at the edges of the network, which is where these devices live and attach. And so that has, and many IoT applications have requirements that have moved the architecture closer to the edge. We saw this phenomenon of cloudification of the internet, where we would outsource all of our resources like storage and compute and data management and control to these cloud data centers, remote cloud data centers, which are very centralized. We saw that happen, in the last couple decades. As a result of the Internet of Things and all the data, and then these new kinds of requirements, we're seeing the pendulum swing back and now moving to more of an edgification of the internet. And what I mean by that is that there are applications for which these back-end cloud data centers, they are not only unsatisfactory in terms of what they can't really meet the requirements, but they cannot meet the requirements. It's not unsatisfactory, it's just we need a completely different architecture. So and those kinds of requirements are things like, the sheer volume of the data isn't going to fit over the network, or the latency to reach the back-end data center is too great. So you have to act on the data, analyze it, act on it locally. Sometimes there are issues regarding the trustworthiness or the trust sensitivity of the data. Like if you think about HIPAA rules or intellectual property, like for many reasons, you might not want to release your data to a cloud or to somewhere else, or you may not be allowed to because of regulation, because of the law. And then there are issues around the cost or the energy consumption to move that data. So all of that has conspired to move the internet, the conventional networks towards, by conventional, I mean, I'm not talking about the utilities just yet, but there's this edgification that's happened where all of those resources around compute and storage and networking and data management and control have now migrated to the edge. And that's what's referred to as edge computing. Now there's this parallel phenomenon going on in the utilities. I would wager that there's this kind of edgification that's been going on in the smart grid as well, or the electrical grid. And so, we could refer to that as grid edgification, but this is all due to the fact that we're integrating in renewables at increasing rates. And as that demand increases, there's the modernization of the grid and tremendous scale out underway, not least of which is because, again, kind of referring to the larger trend that there are many states and countries and industries that are saying we're moving to the electrification of transportation. And that may lead in turn to, in some states in the United States, about 40% more substations and secondary substations. And so that's a huge amount of growth in the electric grid that is going to be coming. And all of that is happening at the edges of the network. Those substations are, you can look at them as the data centers or the localized edge data centers of the electrical grid. And they serve as control points for the potentially, what's going on in the back end, the backhaul of the utilities network, and what lives on the other side, which is all the built out buildings and campuses and so forth that need servicing. Now, these edges that are arising, these are often, the edges in the electrical grid are often referred to as microgrids. And they have an interesting property, which is that they allow, of course, these edges can be and are required to be by law if they generate more than a certain amount of electricity to be attached and report their capabilities to the back end. But they have this nice property that they can also be, they can operate independently. And so this brings us full circle to like your question about wireless networks. And the issue might be, we have a lot of this edge architecture happening. These substations kind of are in an interesting place to parlay like what's going on in the internet and what's going on in the electrical grid. And the more things get distributed, of course, the more they need networks. Now, the way that the wireless technologies fit into this picture is typically for keeping track of the smart meters and for distributed automation. And this is typically done through private wireless networks. And the property about the private wireless networks, like microgrids, is that they are designed to give control, private control of your network in order to reach and to meet certain requirements, like reliability, which is so important to the utilities. And so this is the way in which these private wireless networks bring some value to the ecosystem and this kind of emerging and increasingly more distributed architecture.
Yeah, and you mentioned reliability, but I would like to also talk about the time, the latency constraints, and so I've been doing a lot of work with utilities, and I'm a wireless person, so what do I know about utilities? And what I learned in the process was absolutely amazing, because if you think of what is it they need to do, it's not just talking to their staff as they go around and they're sort of out there, but for instance, the grid it's really crucial that you manage it in a very latency is really important in the grid. When you have everything sort of a major disruption, oftentimes is created by things not happening in a very short time. So the grid is actually a little bit, when you think about it, it's just like a wireless network, where if things do not work well, everything sort of falls down, because you end up having some effect. So when you think about utilities, the initial thought that I had was like, well, you just need to do some signaling, some sort of like making sure that everything works okay. But that's not really the case. You do need to have a really hands-on management, which is not only reliable, but it also has very low latency. And so it's not, it is actually a lot from a sort of a processing computational infrastructure point of view. It's quite demanding. And that's why the edge infrastructure is so important, because sometimes that kind of reliability, that kind of latency, you can only get through a somewhat distributed architecture. Just put everything in the cloud, it's not going to happen. But they still need the cloud for some applications. So there is so many needs that need to be fulfilled. And some is going to be private networks, some is going to be public networks, but it's a huge thing. One other thing that maybe we should talk about is the issue about emergencies, which could be, in California, you guys had your own share of, wildfires, and
Right.
we could have also security threats, or situations where you do need to have a way to deal with issues, and utilities are not causing the problem, but they have to deal with it.
Right.
So
In
how do
fact,
you see that?
there's some studies that show that the incidence of billion-dollar weather-related incidents is increasing dramatically. Like in just the last 10 years alone, the numbers of billion-dollar weather disasters has more than doubled. And that's enormous. And that, of course, renders the utilities sort of fragile when you've got not just wildfires, but extreme events like what happened in Texas just this year. And so, yes, wireless is, from an emergency standpoint, a critical technology to have in your arsenal.
Yeah, and then sometimes they have also like solutions that you just deploy as you need. So it's sort of like it's even beyond the edge. It's not only at the edge, but in the edge when you need it. So now we have a couple of questions in the chat. Now, we're going to be nice today, and we're going to take your questions from the chat, but the questions should go in the Q&A. And this is because this way, if you send it to the chat, nobody can see it. If you send it in the Q&A, everybody can see it. But we do have a question about should there be regulations that require both consumers and businesses to generate a certain percentage of their own energy from renewable energy sources? What do you think is feasible and reasonable? Now, I'm going to answer this question from being in Seattle, where, well, you can tell me that I need to put a solar panel on my roof, but well, actually, they do work in Seattle, but they don't work as well as they do in California. So I think that, you know, you have to be a little bit careful about how renewable can I be if I live in Seattle. But there is a point. There is a point that we need to be. Is there a regulatory scope here as well to address that?
Right, and this is also why the market for renewable credits has flourished, because exactly of this mismatch between Seattle not being a sunny place and solar panels, you know, so you can buy your credits elsewhere. However, one of the issues around raising, you know, talking about data centers and the co-location with hydroelectric and microgrids is to really move the discussion to say, okay, if the world is going to be populated now, not only with hyperscaler data centers, but also with edge data centers, should we be learning from our larger brethren and think about the co-location of renewables with these new kinds of edges? And one of the properties about edges is that they really have migrated to many places in the built-out infrastructure. Almost any infrastructure that exists, if you have a physical location, it becomes a place where you can site resources and compute and so forth. And so it begs this question of, could we do this co-location of microgrids and edge data centers at smaller scale than the hyperscalers? And could we, for, you know, getting back to the question that was raised, could that help the general populace and businesses to meet some of these demands that are beginning to be discussed in certain states?
Yeah, and I guess the issue is that yes, you need to whatever regulatory regulation you might introduce, a key to the success is to make it possible to meet the requirements of the regulation, right? So it's really important to create a situation where all of this can be done in a way that is not overtaxing or is not, you know, so that people can do it. Because I think that a lot of businesses, you know, as you mentioned before, individuals are happy to do it, but you need to have a good infrastructure to do it. So now we have another question here. Jim, thanks for moving your question to the Q&A about different wireless technologies that are used. So Zigbee, Wi-Fi, and 5G. Do you see a convergence around 5G? And I think that you raise a very important issue. There is not going to be a single technology that's going to solve all these problems. Utilities have also specific bands allocated to them, like in 900 megahertz in the US. And so the question, I guess the opportunity and the challenge for a utility is to figure out how you put all these technologies together to get what you need. Because Wi-Fi, it's very good in some environments, but it doesn't give you the wide area coverage that 5G would give you. So we need to utilities have a more complex task ahead than in the past, because there's many more technologies, very powerful, but the question is, how do you put them together? And if maybe you can tell us about what is that you see when you talk to the utilities. What is that you see them as? How do they handle these issues, or what are the issues that they have to face as they consider wireless or
Right.
any?
Yeah, I think that the way to view this is really one of the things that the private wireless networks allows for the utilities is better communications between the utility grids and these distributed energy resources. And these are things that are privately owned wind and solar and storage assets. And sometimes they're utility owned, either they're bought or they're contracted. And so being able to have communications through probably, private LTE or 5G leads to better insights for those assets. I was referring to earlier the Rule 21 in California that requires these, the microgrids of a certain size that are producing a certain amount of electricity to have to be connected to the larger, not just connected to the backhaul, but to report on their assets. And in order that we move towards greater optimization of distributed insights, and because what we're really wanting to do is to understand on a second or a millisecond basis, really having more granularity to the information about the supply, kind of back to our earlier conversation about the supply, that many of these microgrids are private microgrids, and yet the utilities, so there's an interesting dynamic between, the utilities want to know what's out there, and in order to do that, they really need measurement information coming from these electric grid edges. And so given that this power fluctuates, every second of every day, that kind of information needs to be shared more holistically so that the supply and demand can keep up with each other.
And also, I guess it sort of goes the other way around too, because use from homes and businesses can also be managed to meet the supply. So you can run, maybe you don't want to, but you can arguably run your laundry at night when there is more energy, and that might cost you less. So there is also the other way to manage consumption.
Right. I mean, and I think that is a trend that we would like to see happen, not just in the big data centers, at the edge data centers, this movement towards what we've been calling carbon neutral computing, which is, can all of the computing be offset by, or can the footprint of the computing be offset by renewables? And some of that is this time shifting. Now, that's again at a larger scale than, say, your house or a campus or a building. And so the question is, does it make sense for that kind of information to permeate all of the built out infrastructure so that anything that we build out at this point is carbon aware, in hopes that it will eventually be carbon neutral, or that we can at least tamp down this mismatch?
Yeah, absolutely. There is a lot that can be done. Now, if we go back a little bit to sort of more the how the technology is used in the recent CBRS auction, we had utilities paying way more than anybody else, pretty much, way more than the mobile operators for the licenses. So clearly, they see the value of licensed. I mean, well, mid-band spectrum that is typically licensed. To deploy their infrastructure, and that would suggest that they're not just trying to deploy wireless infrastructure in their sort of locations, but sort of probably a wide area network. And they're interested in private networks, so it's a network where they control the assets, they own the network, and so. Can we talk a little bit about, how do you see that going? Because clearly, as you say, reliability and security is a major issue. And if you own the network, you have much more control over that. So how do you see? Because it just seems like this is an area where you do want to have utilities are still going to be using public networks, public cellular networks, but also private networks become really important. So at the edge, private, so they can have full control and do exactly what they need. That's maybe what are you seeing in that respect?
Well, kind of back to Jim's question about the different technologies. I think, well, first off, let's say that the CBRS, the purchase of that spectrum is interesting because it, cues up this ability to roll out some private wireless networks. And in fact, there were 12 utilities in the US that purchased spectrum to use it in that capacity. And as a result of that, you could even argue that the utilities are the largest operator of private wireless networks. And the goal, of course, is to use that to, as in some sense, an umbrella technology as an overlay over all these disparate technologies that are being used for the different kinds of use cases that are supported by utilities. And so you can see it as kind of the data bus that unifies all of these other technologies that already exist.
Yeah, absolutely. And so I think that there is a lot of innovation there as well. And so it's I think that what we're seeing is that new demand, then they need to be more sustainable, renewables and things like that, and they need to move beyond legacy. So there's all of that, and there is new technology that is actually going to help utilities, which is all very good. But at the same time, and again, from my experience working in both the utilities and in other verticals, when you add a new technology which changes the way you do things, it's not like you don't add the technology in a vacuum. You add the technology in an organization that has a culture. Now, I'm not saying that the culture is slowing down the adoption of technology, but although in some cases it does have that effect. But the question is that how do you introduce the technology within a culture in a way that is actually helpful, and how can you make it happen so that it's not an imposition of a technology that everybody hates and then it doesn't work, not because the technology doesn't work, but because there is no fit with the existing culture. So can we talk a little bit about how do you see that wireless is going to change um, the operations, the way utilities work? So it's not just they're going to be helped, but they need to change to make sure that they take full advantage of the technology. If that
It's a great question. I mean, it remains to be seen how, because again, these are sort of new, the purchase of the CBRS was recent. The signaling and the kinds of data that runs over these networks is at present not the critical operation kinds of data, but things that are less mission critical. And so, maybe that's a question about, will that, from an evolution standpoint, be something that changes? Because as what we're seeing, 5G kinds of communication as well as Wi-Fi, they are both moving to support technologies like time-sensitive networks. And although the name conveys that, there's obviously a strong need for low latency, one of the other, in order to achieve low latency, there's tremendous amount of focus on reliability. And that's sort of the attribute about the time-sensitive network capabilities that is of interest to utilities. So I don't know culturally whether the usage of wireless will shift in time as these new technologies are onboarded and coupled with the 5Gs and the Wi-Fis of the world. But that remains to be seen.
Yeah. Well, I guess that, there is oftentimes people talk about, people being worried that their jobs are going to go away because clearly with wireless, we have more automation. And so, or at least employees have to do different things. So, maybe training is going to be, utilities might have to get more into training, reorganizing some of the units. The role of an IT unit might change as well. So I think that this is something that, and then the reason why I'm saying this is because as an analyst, oftentimes you say, well, the technology is there. Why don't they deploy it tomorrow? So it's like, why not? You have
Right.
5G. Why
And
can't you
actually,
do
one
it?
of the reasons why not is when the utilities go out, I mean, the utilities are highly regulated. And when operationally they go down, they are severely fined. And so there's a level of assurance that needs to be met before any technology is rolled out by the utilities. And so I think that's where the sort of, as a community, the conservatism comes in because of the mission critical and the economics of needing to have a very reliable infrastructure.
Yeah, and this is something that sort of comes up oftentimes because again, if you're a startup doing something else, you can be much more sort of moving forward. You just get whatever new technology, and that's your point, right? But if you work in not only they're regulated, but they also have a huge responsibility of keeping our power up and running. So clearly they're going to be much more careful. So I think that we need to be in the industry from the wireless point of view, we need to sort of be aware of the fact that change is going to require some time. And it's a good thing because we want to have our electricity still working, which is not to say that new technologies don't work, but we need to make sure that we get the utilities got the comfort level and the reliability level that you need just because it's a new whatever new technology they're using. So I think we need to be realistic in terms of do not expect utilities, even if they have a CBRS license, to launch CBRS in the next month or so to do everything. You know what I'm saying?
Yes.
I think that we need to put it into perspective and not just say, oh, look how slow they are. They need to be slow. They want to be slow. It's in the
Yeah.
interest of
Exactly.
everybody that they don't move too fast.
Yes.
So that's now another thing is, let's talk about sort of the bigger picture. So we talk about there's a single utility, but utilities do not electric utilities do not usually compete with each other. They are operating, and so do you see much of an effort in terms of utilities working with each other? Is there a scope for standardization? We talked a little about regulation, but are they cooperating? Because they don't need to reinvent each of them. They don't need to reinvent the wheel. They have similar requirements.
Right. Well, there's sort of two ways to slice this. One is, of course, as you said, the utilities themselves are not competitive with each other. There is the minor detail, and again, this is sort of where some analysis is needed from a market opportunity standpoint, is the microgrids are often private microgrids, and they are competitive with the utilities because in some ways they take away business from the public utility or the revenue from the public utility in some manner. But you were saying, is there cooperation? So what if microgrids are continuing to increase? Is there some cooperation among microgrids for shared resources, or is there greater cooperation between microgrids and utilities? And then across utilities themselves, because we've mostly focused on the electrical utility, but we haven't really talked about other kinds of utilities. And one of the discussions emerging in the private wireless network discussion for utilities is the sharing of the capability with other utilities. Not only so using the network first and foremost for the operations of the electric grid, but sharing the excess bandwidth and so forth with peer utilities, partner utilities.
Yeah, and I think that that's a great opportunity. Although again, that's going to be something that it's going to require time because to share assets. It's but you can imagine that a utility that builds a CBRS network for the wide area, they can share with the water utilities and other utilities because they cover the same ground. but they're not clearly not competing. And it wouldn't make sense for the water utility to build another network, besides the fact they don't have a license. So I think that that's going to be potentially an interesting fact and an interesting opportunity. Another thing that it's really I think it's quite interesting to talk about is that with all being all sustainable and efficient, utilities tend to get less revenues potentially, because if you're so efficient, so there is something that could be a little bit of like a disincentive to be efficient, because you
Yes.
gain less profit. But at the same time, it's also true that utilities have a huge real estate value. And in telecoms, I mean, somebody said that wireless telecoms is 50% real estate business. Which,
Yes.
which it is, because they have many of them have fiber networks. They have a lot of real estate assets like lampposts. So that's a way for the utilities to be to work on the other end. They can reach all the subscribers. Some are doing fixed wireless access. So this is sort of working the other way around. So they can use
Yes.
wireless to improve their operations and services, but they can also leverage the need for wireless connectivity to basically gain new revenues.
So
I
actually,
see.
that's a great point, because one thing we didn't really emphasize as yet is that one of the motivations for private wireless networks is coverage. We did talk about it in the context of emergencies, but coverage is really important. And so in that regard, they are very much like the telcos. In that telcos, you need access points, you need coverage, and to do that, you need to put in access points in various places. And there is this question about, well, how many do you need, and in what spectrum for coverage? So and there's also this phenomenon that if you have real estate, what can you put there? And once you have the real estate, whether it's an electric pole or whether it's a lamppost, if you can repurpose it to share it with others who may not even be in the electric industry. Now, again, kind of back to regulations, the reality is that the electricity grid was, or an electricity in general, was considered part of the public good in the 1930s. And that means that there's some requirements about reaching, it being democratized and needing to reach all. And so this discussion about whether the internet and internet access could be in some ways piggybacked on the availability of networks for utilities begs the question of, is internet access considered a public good? And that debate has been raging for several years. And we hope that that will lead to sort of a new outcome in the not too distant future. But until such time, it will be a little hard to offer that without having to, from a regulatory standpoint, really lobby for some of those regulations to change. But if it does change, it would be quite interesting and lead to new opportunity.
No, absolutely. There's a lot of different huge potential there. Not too many entities have the same type of reach as utilities. It's not that many. And I know that in the U.S., but in other countries as well, there are a lot of utilities that, like for instance, lampposts, which are pretty much everywhere, and especially in very dense urban areas where you do have them all over the place. So for small cells, it's a good way to go. And there is a lot of there is some work being done in developing form factors for antennas and DUs that would go into a lamppost that can be shared by different operators. And some utilities are also offering network as a service, so that basically they can just it's just an ongoing revenue for real estate owners. And we have a question here from Jim again about ORAN being more or less efficient than traditional wireless networks. And what I would say there is that Open RAN is actually a great opportunity for private networks in general and utilities specifically, because you don't have to deal with a legacy network. So Open RAN is a more sort of difficult. I mean, if you already have a network, to add Open RAN to it or to move to Open RAN, it requires a little bit more tweaking. But if you have a greenfield network, then Open RAN is much more, it's much easier to deploy and much more effective. And so, yes, that's that can be more effective, but you have to really look at exactly what is that utilities are doing. But there is a lot of work being done in Open RAN for private networks specifically, because the requirements are a little bit different.
And I would also add that although I don't know the answer to the question specifically around, is it more or less efficient? I do know that there are efforts to standardize in an open manner, open network edge services in the way of things like openness, which was launched earlier this year to securely onboard and manage new kinds of edge services for on-premise and network edge. And within that body, that organization, it's an industry forum, there is a working group focused on the green edge, not surprisingly, to address some of these issues about energy efficiency. And in fact, some of this dialogue around carbon neutral computing, we've been in dialogue with some of those involved in openness and the green edge around not just energy efficiency, but kind of going to the next level and saying, it's not just using less energy, but the quality or the carbon intensity of the energy. Could some of the metrics and measurements that they are comprehending also include carbon intensity to encourage and incent the usage of renewables? And what I mean by that is that what we really want to be doing, back to the data center analogy, is really routing our time elastic workloads towards the excess renewables that are out there. In order to do that, we have to know where the excess renewables are, and then the whole orchestration framework has to be carbon aware. So those are some of the related activities around ORAN.
Yeah. Actually, I see a follow-up question from Jim, which I think it's subtle but very good question. So if you have a public network, there's some level of consumption, but if everybody starts building their own private network, aren't we just driving more energy consumption? So if we just look at it, utilities, it's like, okay, why can't you use the public network and keep consumption down? And I would say that is actually, it's a good
great question, but it's very difficult.
At the same time, you want to, okay, my answer to that is that you should not deploy a private network where the public network can do. So if the public network can serve the purpose, it's cost efficient and energy efficient to use the public network. It's not just the energy consumption, it's cost. So from a utility, you only want to deploy a wide area network if it makes sense, both financially and that's why I think CBRS helps, because it has a better propagation. If you were to do it in 6 gigahertz or Wi-Fi, that would be ridiculously expensive and wasteful to do the wide area. So you need to really look into this, but at the same time, we also don't want to be in a situation where you do not have a network because it's using too much energy. And you should be able to prove that the benefits of the network outweigh the increased use of energy.
Right. And I think this kind of goes back to why it's important to create this umbrella network or any kind of connectivity that's going to bring back measurements and data collection at all these assets throughout your infrastructure, so that you can analyze them and create more efficiencies and understand the pain points in your infrastructure. And so hopefully one of the pain points is your carbon footprint, and that we can create some joint optimization around, what do we need to deploy in the way of coverage, while at the same time staying within or aiming for some percentage reduction of carbon footprint over some period of time. So I think that's where the distributed intelligence and AI really will shine, is how to balance those things.
Absolutely. I think we're at the top of the hour, so there's more questions coming, but we're gonna let everybody go on with the rest of their day. So thank you so much. Thank you, Eve. Thank you, everybody in the audience. And let's hand it over to you, Kendra, again.
Great. Thanks, Monica and Eve, for that wonderful conversation. That will conclude our webinar for today. A recorded version of the webinar, as well as an audio version, will be available on the sensafili.com website in the coming days. And we'll also have a Senza Fili tech brief entitled Wireless for Utilities 5G or Wi-Fi 6 that will also be available on the sensafili.com website. There will be more information. And while you're there, please do sign up for future Sparring Partners webinars. Thanks again, and we'll see you at future events.